This engraving celebrates a cable message between Queen Victoria and President Buchanan. The cable would be dead within weeks.
Dead? Then what exactly happened on August 16th, 1858?
An official exchange crossed the Atlantic. Victoria offered friendship. Buchanan answered with hopes for peace and liberty.
So the diplomatic moment was real, even if the infrastructure behind it was not ready.
Very real. Newspapers printed the words beside portraits, flags, ships, crowds, and a wire joining continents.
Why did one message feel like the world had changed?
Because a reply no longer had to wait for an ocean steamer and another ocean steamer back.
The Atlantic had enforced delay. Telegraphy appeared to replace that delay with an electrical pulse.
Not instantaneous, though. Those early signals were painfully slow, and the cable was already behaving badly.
Then, the useful question is not whether the message crossed. It is why crossing once was easier than working every day.
Start with the object. What had they actually lowered into the ocean?
A copper conductor wrapped in gutta percha insulation, then armored with iron wire. Electricity protected from the seawater and enormous strain.
And they needed enough of it to cross from Ireland to Newfoundland.
About 1,600 nautical miles along the chosen route. Too much for one ship in 1858.
So 2 ships each carried half?
Yes, Agamemnon and Niagara met in mid-ocean, joined the halves, then sailed away from one another.
That splice had to survive a storm, deep water, and both ships pulling the Enterprise apart.
The whole cable faced that violence. It snapped on earlier attempts, and paying it out could bruise or kink it.
Was the finished cable at least consistent?
No. Sections came from different factories, and even the iron armor twisted in opposite directions at a joint. A continental link built like a rushed prototype.
A heroic prototype, perhaps, but celebration made its defects no smaller. Physical weakness explains breaks. Why were intact signals so hard to read?
A long submerged cable stores electrical charge. A sharp pulse enters, then arrives broadened, faint, and smeared across the next pulse.
Like a clean tap, turning into a long echo?
As an analogy, yes. The receiving operator had to separate overlapping traces without pretending the echo was another letter.
William Thomson expected that?
He modeled the delay and favored gentle signaling with very sensitive detection. His mirror galvanometer made tiny currents visible.
Then why push more power through the line?
Wildman Whitehouse trusted forceful high-voltage equipment. Stronger shocks could produce a readable response, but they stressed the insulation.
So, a weak signal tempted the operators to attack the cable harder.
Exactly, and this cable already contained faults and laying damage. Voltage was an aggravating cause, not a single lead culprit.
That is less satisfying than one villain, and much more useful.
Failure belonged to the system. Manufacture, mechanical handling, electrical theory, instruments, testing, and decisions under pressure.
How long did the public triumph survive?
Only several weeks of troubled service. The line carried hundreds of messages, weakened, and finally fell silent.
The exact summaries vary. 3 weeks, under a month, or a final loss later that autumn.
The safe conclusion is simple. The first completed Atlantic cable was a short-lived demonstration, not durable infrastructure.
Did investors treat that as proof the ocean could not be wired?
Some confidence collapsed, but an inquiry separated impossible physics from fixable workmanship, testing, and operating practice.
That distinction kept the idea alive through financial strain and civil war.
The next cable was stronger, and it still vanished into the Atlantic.
What changed before the 1865 expedition?
Better insulation, stronger armor, factory testing, shipboard electrical checks, and instruments designed for a long submarine circuit.
And a different ship?
The Great Eastern. It was huge enough to carry the entire cable, so the expedition could start in Ireland and keep paying out.
A failed passenger giant, finding the one job that needed its scale.
The cable tested well as the ship crossed. Faults appeared, crews hauled sections back, repaired them, and continued.
How near did they get?
Near enough, but Newfoundland was the next landfall. Then the cable snapped, slipped away, and sank into deep water.
After all those improvements, another line lost overboard.
But this failure carried different evidence. The cable had transmitted during the crossing, and Great Eastern had handled it successfully for most of the route.
They marked the position and tried grappling hooks until time and fuel ran down.
Failure, but now with a map back to the missing piece.
What made the 1866 voyage more than another hopeful repeat?
The improved cable, Great Eastern, continuous testing, gentler signaling, and practiced handling returned together with a fresh length.
On July 27th, Great Eastern reached Heart's Content, Newfoundland, with the new cable working.
That alone created the durable link 1858 had promised.
But they went back for the cable lost the year before?
Yes, they returned to the marked area, grappled the deep seabed, raised the old end, tested it, and spliced on new cable.
That part always feels impossible. Finding a thin line in an ocean.
It took repeated attempts and careful navigation. In September, the recovered line became a second working connection.
2 links, one newly laid, one literally recovered from failure.
So, what changed between the royal message and the durable network?
Not ambition. Measurement changed. Manufacturing changed. The ship, instruments, tests, and operating habits changed.
The first cable proved a signal could cross. The later work proved a service could continue.
That is the structure beneath the celebration. Infrastructure becomes ordinary only after failure becomes specific.
That's where we'll pause this conversation. Come back for the next story.